Today we're going to break down some brand new research that might have just cracked one of AI's oldest, biggest problems: how to create an intelligence that can actually learn for its entire life, just like you and me.
It seems like a pretty simple question, right? But for artificial intelligence, the answer, until maybe right now, has been a hard no. I mean, think about it. When you learn to play the guitar, you don't suddenly forget how to ride a bike. But for an AI, learning a new skill often means totally wiping the slate clean.
And this right here, this is the fundamental difference. Our knowledge is cumulative. It all builds on itself, right? AI, on the other hand, suffers from a problem with a really dramatic name: catastrophic forgetting. And honestly, it's exactly what it sounds like. Learning task B can literally erase all knowledge of task A. Poof, gone.
So let's really dig into what makes this problem so catastrophic for AI. Because once you get your head around this, you'll see just how much of a game changer this new breakthrough really is. Imagine this. You spend years becoming an expert chef, right? You know all the techniques. And then you learn one new recipe for a fancy dessert, and suddenly you forget how to even boil water. That is catastrophic forgetting. And it's been this massive, massive roadblock preventing AI from developing that general adaptable intelligence that we humans have.
Now, researchers have been trying to solve this for a while, and they came up with a pretty clever workaround. It wasn't a perfect solution, not by a long shot, but it was a really big step in the right direction.
And that fix is called low-rank adaptation, or just LoRA for short. Now, before LoRA came along, teaching an AI a new skill meant you had to retrain the entire gigantic model. It was super slow and unbelievably expensive. LoRA's idea was basically, hey, let's stop doing that. Instead, let's just create these small, efficient add-ons for each new task.
Think of it like this. Instead of trying to rewrite the AI's entire brain, LoRA creates these tiny, specialized mini-brains for each new skill. If you've ever used an AI image generator, you've definitely seen this. You download a LoRA for an anime style, another one for photorealism, another one for a specific artist's look. But here's the big catch. You end up with hundreds of these separate little brains, and none of them can talk to each other or learn from each other. It's not a truly integrated intelligence. It's more like having a giant toolbox filled with single-use gadgets.
And this is where the new research comes in. The scientists behind this new paper had a wild hypothesis, a crucial aha moment that just changed everything. What if all those separate mini-brains weren't so separate after all?
Okay, so this is the central idea from the paper. It's a bit of a mouthful, I know, but in plain English, it's suggesting that all these different skills, all these different mini-brains, are secretly being built on top of the exact same foundational knowledge. It's like they're all speaking a hidden, common language.
And this graph, this is the proof. This is the smoking gun. What you're looking at here are different AIs, the red, green, and blue lines, and they're all learning totally different skills. See how they all start at the bottom, all over the place? But watch what happens. As they learn, they all climb up and converge into that same shaded orange area at the top. This proved it. There is a shared foundation of knowledge they all end up discovering.
So, armed with this amazing discovery, the researchers built a brand new method to take advantage of it. They call it SHARE, and it's designed specifically to find and build upon this shared foundation. The process is actually, in concept, brilliantly simple. Step 1. It identifies that shared foundation we just saw. Step 2. When a new task comes along, it trains a tiny, temporary little piece just for that one task. And then, Step 3, and this is the magic part, it intelligently merges that new knowledge back into the shared foundation, making the entire model smarter and more capable than it was before.
In this diagram right here, this shows you that three-step process in action. Over on the left, it initializes with the skills it already has. In the middle, it adapts by learning that new temporary piece. And then finally, on the right, it merges that new knowledge back into the core model, making the whole thing smarter. It learns, and this is the crucial part, it remembers.
Okay, so the theory is really elegant. It sounds great, but does it actually work? Well, the results are, and I'm not exaggerating here, they are absolutely stunning.
Get ready for this. 100 times 100x fewer trainable parameters. Now, parameters are kind of like the dials and knobs an AI has to tune to learn something new. This new method needs to adjust 99% fewer of them to learn a new skill compared to the old LoRA way. That's just an incredible leap in efficiency.
And of course, because you're not saving hundreds of separate mini-brains anymore, you get an absolutely massive memory savings. We're talking over 280 times.
This is what makes powerful, adaptable AI accessible on much, much less powerful hardware. And here is the real kicker. All of that insane efficiency doesn't come at the cost of performance, not one bit. Just look at this table. The old LoRA method used 7.2 million parameters to get that performance score. The new share method, it uses just 12,000, a tiny, tiny fraction, and achieves basically the exact same result. It's really the best of both worlds.
And if you want to see what this power looks like, check this out. On one side, we've got Elvis in a pop art style. On the other, a poster of Obama in an Art Nouveau style. What's so incredible is that both of these images and dozens of other styles were generated by the exact same model. Not a different mini brain for each style, but one single continually learning model.
So let's zoom out for a second. What does all this mean for the future? Because this goes way beyond just a clever technical trick. This is a big deal.
So why does this matter so much? Well, for one, it paves the way for true lifelong learning in AI. It means we can have one scalable model instead of juggling hundreds of them. It's way more sustainable, using far less energy and computation. And it makes powerful, personalized AI a real possibility for everyone, not just for giant tech companies.
At the end of the day, what we're looking at here isn't just another small improvement. It's a fundamental shift in how we can actually build artificial intelligence. It's a blueprint for making AI that grows, that adapts, and that learns in a way that is finally starting to look a little more like us.
Which brings us to one last really exciting thought. We are right on the verge of an AI that never has to forget. The only question left is, what in the world are we going to teach it next?